Cystic fibrosis. Cystic fibrosis history has been around dating back to the Middle Ages, describing children as having salty skin and damage to the pancreas. In 1938, pathologist Dorothy Anderson labeled this disease as cystic fibrosis of the pancreas, due to the damage it did to children who died of malnutrition. It causes changes in the electrolyte transport system, which causes cells to absorb too much sodium and water. In the 1980s, scientists discovered the gene CFTR was responsible for this disorder. Cystic fibrosis is a progressive genetic disease that causes persistent lung infections and limits the ability to breathe over time. Characteristics of cystic fibrosis include very salty tasting skin, coughing up with phlegm, wheezing, shortness of breath, poor weight gain, bulky, greasy stools, and male infertility. The prevalence of cystic fibrosis is the most common genetic disease within the Caucasian population in the United States. The disease occurs in 2,500 to 3,500 white newborns. The molecular cause is the result of mutations in the cystic fibrosis transmembrane regulator gene, which is also known as CFTR. It's what causes abnormality viscous secretions in the cells of different epithelia. The mutations of this gene consist of 27 exons and are located on the long arm of chromosome 7. The mode of inheritance is cystic fibrosis is inherited in an autosomal recessive manner. The person must have a mutation in both copies of the CFTR gene in each cell. Those with CF inherit one mutated copy of the gene from each parent, which is known as the carrier. Here is a pedigree that we did in class. As you can see, Marilyn and Richard one of them is a carrier and the other one is not. Richard has the double CC lowercase, which means he's recessive, and he's the one who has the disease. If you look down, Danielle is recessive and she has the disease as well. And then Danielle and Brian's possibility of future offsprings that are not affected would be 100%. Genetic testing. There are multiple ways that individuals can get genetically tested for cystic fibrosis. These include a mutation panel, a chromotricin test, a respiratory screen, a newborn screening, sweat test, and a trypsinogen test. These tests aren't mandatory, but they are highly recommended. If a woman is pregnant and wanted to know if her baby had CF or is a carrier, she can have a prenatal test. Chorionic villus sampling is a test that checks tissue from the placenta to see if the baby has the genetic condition. This is done 10 to 12 weeks pregnant. Early detection is always key with any type of disease or condition. Testing costs vary and your insurance company may or may not cover the testing. The cost of a single mutation for cystic fibrosis is $20. Treatments for cystic fibrosis include airway clearance to help loosen thick mucus in the lungs, inhaled medication that opens the airways and thins the mucus. They may include mist or aerosol, and they're inhaled through a nebulizer and includes antibiotics. pancreatic enzyme supplement capsules are used to improve absorption of nutrients because there's a lot of CF patients that have malnutrition. CFTR modulators are to target the defect in the CFTR protein. Here at the very top right is how the mucus looks like with a healthy patient around the lungs, the trachea. And then the bottom is all the mucus for CF patients. Pathway from gene mutation to syndrome is cystic fibrosis, infection, inflammation, blocked ducts, impaired mucosal defense, altered secretions, ion transport, CFTR protein, and CFTR DNA. And then on the left is the inheritance of cystic fibrosis, if one is a carrier, one is not, and the different children that they have, and if they are a carrier or if they do have the disease. And here are my references.